Hello. In this WAGO tutorial, we will show you how to use virtual objects in the WAGO Energy Data Management application. The WAGO Energy Data Management application includes the area of virtual objects. In this video, we will first discuss mathematical objects and controller objects and then present two common applications using two examples. After that, we will briefly discuss the energy, modem, and accumulator objects. We will start with the mathematical objects. In the previous tutorials on WAGO Energy Data Management, we demonstrated how power and energy values are recorded, logged, visualized, and sent. For this, we used this small setup with an energy measuring clamp, for example, to record the total effective power of Hall 1. Of course, we can simply expand the setup with a second 75495 energy measurement module to additionally measure the total effective power of Hall 2, for example. In the Inputs tab, select the Power Measurement Modules tab and then the 75495 module. The second module can now be selected at the top and we create a data point for the total active power of Hall 2. Provided that both data points are activated in the selective logger, the two values can also be displayed in the advanced visualization. But now we would like to have a display showing the total active power of both halls as a sum. And this is exactly a common application for a virtual mathematical object. The goal is to configure a virtual data point that then displays the total active power of both halls from the two real data points, power Hall 1 and power Hall 2. In the Virtual Objects tab, we go to the Mathematical Objects. With Add Object, a new data point line is added and we open the Settings window. In the upper section, we enter a name, location, and the unit watt. With a tick, the object is activated and we add a value with the plus button. The cogwheel icon opens the selection window where we can choose between input and virtual. In our case, it is an input, but you can see that it is also possible to make calculations with previously created virtual objects. If input is selected, we choose the total effective power of Hall 1 in the data point reference. We add the total effective power of Hall 2 in the same way. In the formula field, you can devise the wildest calculations for the values created. In our case, a simple addition is sufficient. First, the field must be activated and then a formula can be entered similar to a spreadsheet. We start with an equal sign. As numbered in the list above, the data points can be called up and added with a $sign and the list position. To be able to display the value in the advanced visualization, it must be added to the selective logger. Click OK to confirm, and the virtual object is created. The summed value is displayed. If we switch to the advanced visualization, we now also find our virtual object for the summed up total effective power of halls 1 and 2 when selecting the data point. Another common application for a virtual object is the drag indicator. This is a display that shows a maximum or minimum value over a defined period of time. In our case, we want to monitor the total active power of halls 1 and 2 over a period of 24 hours and determine the maximum power consumption. To do this, we switch to the Controller Objects in the Virtual Objects tab and create a new object. In the Settings window, we assign a name and set the unit to watts. Under Write, we tick the box for activation and add a new value. In the value selection, we select the type virtual and then also find the total active power of both Hall 1 and Hall 2. In the mode section, we can select whether our drag indicator shows the maximum or minimum value. Then we have to specify a pulse that resets the drag indicator to the current value. This can be, for example, a digital input that we have then created as an object in the EDM. Or the pulse source can be the system time, resetting the drag indicator once an hour, for example. In our case, where the pointer is to be reset daily, we need select timing as the pulse source. We do not need UTC time here, we use the controller time. For repetition rate, we select daily, and for start time, we enter the start time as a full hour. If the drag pointer is to be reset daily at 9 AM, we set the start time to 9 and confirm with OK. For a test, we switch to the Summary tab and see both the instantaneous power and the drag indicator with the maximum total effective power. If we now switch on a load, both values increase. If we disconnect the load from the grid, the instantaneous power drops, but the drag indicator remains at the maximum value. Now we wait until 9 o'clock. And our drag indicator is reset to the instantaneous value. The other three virtual objects are rarely used, so we will only briefly discuss them here. For energy objects, different mean values can be calculated, which could be useful for an energy evaluation. In the settings window, the question mark next to mode opens the help window, which explains the basis for the various calculations. The modem objects are available when using the PFC with a GSM modem. And you can query various states such as signal strength, SIM status, and network status of the modem. For example, to restart the modem in the event of an error. The accumulator object is used to represent data points that are available without a time base as time-dependent variables. Typical applications include simple counters, such as water meters that merely count consumption in cubic meters. If these are then to be displayed as cubic meters per hour, this can be implemented with an accumulator object. And that concludes our tutorial on virtual objects in WAGO Energy Data Management. Please give us a thumbs up if this video was helpful, subscribe to the channel, and contact the WAGO Support Center if you have any questions.